we shall have something more about chemistry of water. And as we know that water is indispensable for us, it has got its own characteristics. It's a chemical compound formed by two atoms of hydrogen and one atom of oxygen. And here are the physical characteristics. And of course, the molecular formula is H2O, but its structural formula is with a bond angle of 104.45, and the distance between OH bond is 94.84 picometer. It undergoes hydrogen bonding. Their molecules get associated with oxygen atom gets associated or bonded through what is known as hydrogen bond, relatively weaker but quite stronger to hold the water molecules together. And that's why it has got a high boiling point, low freezing point, dielectric constant is high, and heat of fusion and heat of vaporization is also high. It has a high surface tension, high thermal conductivity, and oxygen atoms are tetrahedrally linked with four hydrogen atoms in case of water. And therefore, to be more clear, here is a structure. Hydrogen bond, the tetrahedral uh, stereochemical structure of water, and also the bond angle of OH bond between two OH bond is 104.5. And again, the same thing is clarified to us that it has a high boiling point, low freezing point, has high dielectric constant, high heat of fusion and heat of vaporization, high surface tension, thermal conductivity is also greater, and it is available to us in the solid state, which is known as ice. It has got a cage-like structure. Oxygen atoms are tetrahedrally linked with four oxygen atoms to provide a cage-like structure in ice. Now, let us have certain chemical reactions of water. We know that water is universal chemical agent, I'll say, because it can react with metals, it can react with non-metals, it can react with oxides, it can react with basic oxide as well as the acidic oxide. It can react with nitride and calcium cyanide or even hydrides. And not only this, it undergoes hydrolysis. It can react with different other reagents, forming organic compound like acetylene or methane even, and it gets hydrated. Many salts, when it comes in contact with water or moisture, they get hydrated. For example, copper sulfate, it gets hydrated as CuSO4 5H2O. Similarly, sodium sulfate Na2SO4 10H2O means certain molecules of water get associated with a molecule of different salts, which is known as hydrated salts. And likewise, there are many other reactions such as hydrolytic reactions. So we shall take it up one by one, and as we find here, it reacts with metal. Different types of metals react under different conditions. It depends upon their electropositive nature. For example, when sodium reacts with water, the reaction occurs violently, even at room temperature, giving out hydrogen, and of course, an alkali is formed. But for magnesium, which is a second group element, we need to boil to get hydrogen and magnesium hydroxide. Now, how about iron? Iron in the solid state also gives out hydrogen, but under drastic condition, we'll say it is drastic condition that when it is steam heated or in presence of steam, you get Fe3O4, that is uh, iron tetroxide. And hydrogen is given out. And when it reacts with non-metals, same thing happens. Non-metals react with water, particularly fluorine, forms corresponding acids. And it has to be taken carefully that at room temperature, two types of reaction occurs with fluorine. In one case, you get ozone and you can get oxygen also, depending upon the extent of uh, heating and conditions. Oxides react with carbon dioxide, sulfur dioxide. These are acidic oxide. They react to form corresponding acids, sulfurous acid or carbonic acid. Basic oxide form corresponding hydroxides. Now, CO2 and H2O themselves react carbon dioxide to form C6H12O6. Well, these are the important reactions. We need to go through it because they have their own utility. Water reacts with nitrites to form ammonia. With calcium cyanamide, that is CaCN2, you again get ammonia along with calcium carbonate. And with hydrides like calcium hydroxide, calcium hydride, and sodium hydride, hydrogen is given out, and corresponding salts, hydroxides, are obtained. So, these are the important reactions. And now, the reaction of carbides, such as calcium carbide or aluminum carbide, is quite important because they interact with carbides, which is nothing but the C single bonded C, two carbon atoms which have a di-negative charge, and this is found in the crystal structure of carbides. The crystalline structure of carbide shows that these carbides have ionic structure where C is bonded one another carbon atom and is di-negatively charged. So carbides react with water to form alkanes such as aluminum carbide, and we know that calcium carbide reacts with water to form alkene. So this is a very good reaction. Phosphides such as calcium phosphide react to form phosphine, and water shows self-proteolysis. Self-proteolysis means two molecules of water interact to form an acidic hydronium ion as well as the hydroxyl ion. And this is seen when water reacts with ammonia to form ammonium ion and the hydroxide ion, and with H2O, the water reacts with hydrogen sulfide to form hydronium ion, which is acidic in nature, and hydrosulfide ion. So that's there. Water forms hydrates of certain salts which are hygroscopic in nature. They become hygroscopic means they uh, attract a certain number of water molecules with their own molecule, such as copper sulfate is CuSO4 5H2O, sodium sulfate is 10H2O, so Na2SO4 10H2O, and FeSO4 7H2O. Like that, a number of examples are there. So that's known as hydrolysis of hydration of water, salts, hydrated salts. These are the examples. Again, there are certain catalytic property of water. Not only this, water acts as a catalyst also. That because many reactions, or a few reactions, I'll say, uh, occur in presence of moisture, and moisture is nothing but water. For example, hydrogen and chlorine won't react to form hydrogen chloride until and unless a little amount of moisture is there. पानी की उपस्थिति में ये रिएक्शन हो सकता है. Similarly, ammonia and chlorine form ammonium chloride, but this reaction is catalyzed by the presence of moisture. So, and not only this, we know that when salts are dissolved in water, they get dissociated or ionization of salt. They form positive ion and the negative ion. Then water is so important to us that it gets it hydrolyzes different salts and forms corresponding, depending upon the nature of the salt, it forms acid or bases. For example, P4O10, that is phosphorus pentoxide, dimer. Dimer is P4O10, phosphorus pentoxide is P2O5. When it reacts with water, it forms H3PO4, that is phosphoric acid, silicon tetrachloride, gives out silicon dioxide, and HCl. Copper sulfate reacts with water to form copper hydroxide and sulfuric acid. Well, these are some of the important reactions which represent the utility of water, and therefore water has got its very own important chemistry. But this is not the end. There are many other reactions of water which is useful to us, and we shall take up in our next video, and particularly that will contain the interaction of soap with water, that is hard and soft water, and how to use this hard water and how to make hard water soft, that is known as water softening. Okay, thank you. Please do subscribe to our channel.